Hello there guys, and welcome back to another maths video. This is episode 5, and in this video we're looking at rationalizing the denominator. What is rationalizing the denominator? It's a hard thing to sort of explain, but essentially what it is it's when you have a square root number, or maybe it's a cube root, but that's not really what's, you don't normally get a question like that in A-level maths. It's normally a square root, is where you get some number, let's say hypothetically 1, could be anything though, over the square root of a number. So let's say it's the square root of 2. This is annoying. The reason why this is annoying is because long ago, when calculators didn't exist, if you were trying to figure out the value of 1 over, or 1 divided by, the square root of 2, you had another thing coming, because it's just hard to do that. Because what you're doing is, imagine trying to do long division with a number like the square root of 2. If you don't know, the square root of 2, or the square root of any non-square number, so any number that isn't 1, 4, 9, 16, and so on and so forth, or like 1 over those, like 1 over 1, 1 over 4, 1 over 9. Any number that isn't one of those, if you take the square root of it, it will go on forever in decimals. It will never stop, and you can prove that it will never stop, and we will get to that eventually in a while. You can prove that this never, ever, ever, ever stops. You could never finish writing out the decimal expansion of the square root of 2, or the square root of 3, or the square root of 5, or the square root of 6, or the square root of 7, or anything like that. It's not possible to finish writing that out. So dividing by a number that you can't even fully write out, that's not too good. That's not too good. Imagine trying to do some long division with that. Not helpful. So what we do with the rationalizing the denominator is we do something called making it rational. We rationalize it. Now, where does this word rational come from? What am I talking about rational? There are two types of numbers. You can think about it this way. There are rational numbers, so whole numbers are rational. Numbers that you can express as a fraction are rational. So 1/3 is rational, 10/3 is rational, 3/10 is rational, 5 is rational, -3.5 is rational. Because you can just write those as a fraction. Any whole number, let's say the number 9, you can write 9 as 9 over 1. So you can write it as a ratio, that's where rational comes from, between two whole numbers. We call numbers like pi and the square root of 2 irrational numbers because they do go on forever, just like me sometimes, when you get me talking about maths. So, what a perfect segue into actually getting to the topic. How do we make this turn into something which is rationalized? The denominator of a fraction, remember, is the bottom part of the fraction. We want that to be rational, aka preferably a whole number, or it could be a fraction, but we want a whole number really. The reason for that is because if you then divide by a whole number, it's quite nice. It's much easier to find this number when you rationalize it, because you have an irrational number on the top, but you'll have a rational number on the bottom, which means you're just dividing by a rational number, which is okay. It's a bit better. You'll still never find the whole answer, but it's a bit better. So it turns out that any number like this with a surd, which is what this is, so it's a number with a radical sign there. The radical sign is the little bus stop above the 2. It turns out that any number like that can actually be written as a different lot of numbers. You can write this number in a totally different way, and you might not think that they're the same thing, but I'll show you that they are. So, without further ado, let's get into it. What is a fact that you know about fractions? Well, you probably know a few things, but one thing I'm sure you know is if you do the same thing to the top and the bottom of a fraction, it doesn't change the value of the fraction, it stays the same. So, to sort of explain what I mean, let's use algebra. If I say 1 over 2, 1 over 2 is equal to 0.5, it's equal to half, it's equal to whatever it might be. It's always equal to 50%, 0.5, whatever. The amount that I'm paying when I go to get food at a restaurant and someone asks for me to pay, it's always going to get split into 2. So if we timed both sides, top and bottom, by some arbitrary value, x, could be a number, could be pi, could be anything, this is still a half because these just cancel out. You can just get rid of the x's. We haven't done anything really. Or you could write, instead of a half, you could write 5/10. 5/10. Or you could write 4/8. Or you could write 3/6. Or you could write pi over 2 pi if you wanted to. All of these, all of them, and there's an infinite number of them, they all equal a half. But they're all written in a different way. So what's to say that we can't write this in a different way that's helpful, that's actually helpful? Well, why don't we try and multiply the top and the bottom by the square root of 2? Okay, let's give it a go. So, I'll get rid of this arrow. Let's times this by the square root of 2 over the square root of 2. That is just equal to 1, so it's not changing the fraction. It's going to keep the number the same, but this helps us because we're not going to simplify that. We're actually going to just multiply like how we normally multiply fractions. So we're going to have the square root of 2 on the top, because that's 1 times square root of 2. And what is the square root of 2 times the square root of 2? Well, by definition, literally the definition of what a square root is, square root of 2 times square root of 2 is 2, isn't it? So it's the square root of 2 over 2 is the same number as 1 over the square root of 2. But the denominator of the fraction has been rationalized. It's now a rational number 2. If you know the value of the square root of 2, I know roughly what it is. It's about 1.41 something. Just checked what it is. 1.4142 ... forever. But let's keep it simple. Dividing that by 2 is not really that bad to get a good approximation. But doing 1 over the square root of 2, I promise you, is significantly harder if you don't have a calculator. However, I must tell you, nowadays, this is not relevant. You don't really need to do this because a calculator, obviously, can just do that. You can just figure it out, just tell you what it is. It's not too bad. So this is a good skill to have, but it's not actually 100% relevant. Obviously, you can get questions rationalizing denominator. I'm not saying don't learn it. I'm just saying if you're wondering why you would ever do this, the answer is you wouldn't. It's doing maths for the sake of maths, which there's nothing wrong with. It's ancient maths, but we'll get to some newer stuff soon. So I'm actually going to split this video into 2 parts because it's going to get too long. I want to keep these videos short. The second part of this video is about how to rationalize the denominator for harder questions. So for example, I'm going to show you how to rationalize, let's say, if you had a, where a is some number, over, let's say, b plus the square root of c. Obviously, this is a bit trickier. It makes a little bit of a fuss. So we're going to figure out how to do that in the next video. So stick around because that's also part of rationalizing the denominator. Thank you guys very much for watching, and I'll see you in the next one.